Good morning and welcome to the CGD seminar. So today we have the pleasure of hearing from Chris Trisos on journeys in climate risk with policymakers and practitioners. Chris is currently the director of the Climate Risk Lab at the African Climate and Development Initiative. The group he directs integrates data and methods from the environmental and social sciences to inform rapid, just, and equitable responses to the climate crisis. Current areas of focus within the group include climate change risks to biodiversity, including to wild harvested food plants, impacts to the prevalence of infectious disease from climate change, and risk associated with climate intervention strategies, such as solar radiation management. So Chris holds a doctorate from Oxford University in zoology, where he was a Rhodes Scholar. Prior to working in South Africa, he was a postdoctoral fellow for 3 years at the National Socio-Environmental Synthesis Center at University of Maryland, where he looked at relationships between biodiversity and climate change. Chris is a coordinating lead author on the IPCC AR6, where he was responsible for Working Group 2 chapter on African climate change impacts. He's additionally consulted on climate change adaptation for the World Bank, is a science communicator writing forward the conversation, and he co-created Survive the Century, which is a climate change choose your own adventure game. So quickly, as a reminder, questions for Chris will be taken at the end of his presentation. If you're joining us on Zoom, please either put your questions in the chat to have me read them aloud, or you can use the raise your hand function in the options and address Chris directly. And at that, Chris, I invite you to share your screen and begin. Thank you.
Thanks, Monica, and thanks very much for the invitation. Can you see my screen clearly?
Yes, that looks great. Thank you.
Okay, great. So thanks so much for taking the time to listen to me share some reflections and thoughts. And this is really a talk that's journeys in climate change risk assessment and communication with policymakers and practitioners, partly because it's been a chance for me to bring together a bunch of thoughts, many of them which come out of my experience with IPCC over the last 4 years in Working Group 2, and recently with the approval of the synthesis report, and sort of what are some of the sticking issues in how we talk about risk and the complexity that practitioners and policymakers face that I think we appreciate from the science side, but we often don't perhaps give different parts of that enough weight when talking to people in policy and practice, and it can really hold things up. Like in the synthesis report, some stuff around risk meant that a bunch of us didn't sleep for about 52 hours negotiating 2 or 3 sentences with a few governments. So this has been a welcome chance for me to sort of bring a few thoughts together on some of these things, and then happy to answer whatever questions at the end. So just before I really start, to say thanks to a lot of the people in my lab who've been instrumental in a lot of this work, from master's students through to postdocs and research associates. And a lot of the work I'll talk about today has been led by many of the people on the screen here, based at University of Cape Town. So just a quick outline of the talk. I'll go first through a kind of evolving understanding of climate change risk that's surrounded a lot of IPCC work, and then some case studies, quick highlights of how they've been used in different cases, different dimensions of understanding risk, and then talk a bit about what is the kind of transdisciplinary research lens that we're using to try and address some of the historical inequities that drive risk, particularly within parts of the climate change research community. And then ending just with some things about how we might communicate risks and the choices we face to create different climate futures, particularly thinking of different audiences beyond policymaking. So to get right into it with a definition straight up front, this is climate change risk circa the 5th assessment report of IPCC back in 2014, 2015. Where it talks about the potential for adverse consequences for human or ecological systems, recognizing the diversity of values and objectives associated with such systems. And so that's the IPCC risk definition then. And if we look at what does it see as the contributing factors to a climate change risk, or the drivers of that risk, It goes back to 2012 with a special report on extremes, when IPCC came up with the risk definition that it's been using for a while now, which is risk comes from the interaction of some physical climate hazard like a heat wave or a tropical cyclone with some exposure. So that's where are people on the landscape that is the cyclone hitting where people are, how long are they experiencing that? And then some vulnerability. So what is their capacity to adapt? What is their sensitivity to that hazard and exposure? And it's really been thought about in kind of an adaptation and a mitigation sense, in that what mitigation can do is it can stop the size of the hazard growing. And what adaptation can do is it can make people and ecosystems potentially less vulnerable and less exposed to some climate hazard. And a lot of the work in, well, the whole working group 1 really of IPCC is really focused around the hazards. Working group 2 does more on the vulnerability and exposure. And I think better than ever before, the recent IPCC reports really spent a lot of time on vulnerability and exposure. So just some highlights in the African context here. Is really a lot of the climate impacts we see are being driven a lot also by socioeconomic, political, and environmental factors driving vulnerability and exposure. And so just some highlights in an African context here is that over half of the sub-Saharan African workforce is employed in agriculture, and almost all of the cropland is rain-fed. So a very climate-exposed sector where most Africans find employment. And then in our cities, increasing infrastructure and populations in areas exposed to climate hazards, such as low-lying coastal areas. So a lot of rapid urbanization in informal settlements, many people living in informal settlements in our cities, and then many people also in informal employment, so without workplace protections or types of things like sick leave, for example, in the face of climate hazards. And then if we put that all together, there's an assessment that a mortality from a climate disaster or hazard like a heat wave or a flood is up to 15 times higher in the last couple of decades in highly vulnerable countries such as least developed countries in tropical Africa compared to the least vulnerable such as countries in northwestern Europe. And just to go a little further on this, I think we've talked about the low-lying coastal regions and informal settlements, but sort of really at the core of it, a lot of IPCC this time around getting to historical patterns of marginalization and vulnerability. So the summary for policymakers of the Working Group 2 report highlights colonialism ongoing and historical patterns of colonialism as a driver of climate vulnerability and impacts. For example, patterns of land settlement during colonialism that moved indigenous peoples into more climate exposed parts of a country, such as low-lying areas, and then also excluded them from decision-making around social security, all sorts of social processes, including the democratic process completely. So getting increasingly focused on these differences in vulnerability and exposure in human settlements. But to move to a biodiversity example now, when we do risk assessment in Working Group 2, it's often, if you look at that risk propeller at the top, that we're just getting kind of 2 out of 3 of these drivers of risk. So if we think of it's the hazard, it's the exposure and the vulnerability, what you're seeing here is some work I was involved in where we looked at how exposed global biodiversity was to potentially dangerous climate change. Here it's particularly looking at monthly mean temperatures. And the darker colors are when a higher percentage of species have been exposed to temperatures beyond those which we've ever observed them surviving at in the wild. So you can see as we go from 1.5 to 4, particularly in the tropics, more and more species over a bigger area exposed to potentially dangerous climate change. But that doesn't really say much about their vulnerability or their adaptive capacity. It's like, okay, they're exposed to higher temperatures than they have previously, but maybe they could evolve really quickly. We think in many cases probably not, but we don't know for most species. This analysis looks at about 30,000 species globally. Maybe they are better able to move to track certain climates. So a lot of that aspect of vulnerability is missing in this, as it is in many biodiversity assessments, or in some that look deeply into the vulnerability, they don't then also consider exposure in quite the same way. So a lot of the human stuff as well, like exposure to extreme heat for people, doesn't go in depth into aspects of vulnerability or adaptive capacity, such as access to cooling or differences in local environments. And so often, especially in these global scale assessments like IPCC, we're just getting kind of 2 out of 3 of these risk dimensions. This is one I think is quite interesting by Michelle North and colleagues. It's currently in review. I was a bit involved with it, where they tried to kind of look at more of these dimensions, so hazard, vulnerability, and exposure. This is for heat stress to cattle. So on the bottom left there in that map, everywhere you see a red, an orange, or a blue dot is a study that's applied heat stress conditions to cattle, probably in the field. There's some observational studies in here as well. No surprises, there's a lot more of them in developed countries than in places like India and the tropics, and Africa is largely missing. But if you draw these together, what you see on the right here, which might be familiar to many of you, is a kind of relative humidity and temperature axis, where the dashed lines are the thresholds beyond which, if you go to the right of these lines, some combination of temperature and humidity to the right of these lines is potentially, with the red line, potentially lethal to cattle. To the blue line, the right of that, you see large drop-offs in production in things like milk production, and for the orange line, drops in fertility. And so if you then look at this under future scenarios, kind of mapping out where the cows might be in the future, and the increase in heat. If you look on the top here, you're seeing the difference, for example, in Asia or Latin America between a relatively high emission scenario and a much lower one in the gray. But how much of that increase in exposure and in risk, so this is overall risk, the vulnerability, the exposure, and the heat hazard coming together, how much of that is being driven by temperature increase, and how much of it is being driven by other decisions about cattle farming? And on the bottom here, you can see we try to sort of come up with a rough proportional split, where in places like Asia, slightly more of it is from the actual increase in the hazard. You can see on the bottom there's panel F. But if you look in panel G, and then especially in panel H, in the African tropics, a lot of the increase in risk is actually coming from an increase in exposure because of projections of future expansion of cattle farming into tropical areas, such as we're seeing and have seen for a while in a lot of the Brazilian Amazon, with expansion of cattle into already high climate risk areas for cattle. And so really, I think getting at these important nuances, which often, in my experience in the South African context at least, like we don't get enough into these details of the different drivers of the climate risks. And so that was all very IPCC circa 2015 risk definitions, but a lot of those studies are very current and are doing, I'm not knocking them, they're doing a good job. But the IPCC this time around added an extra dimension to risk, which is this sentence in italics here, saying in the context of climate change, risks can arise from these climate impacts, from hazard exposure and vulnerability, as well as from human responses to climate change. And what they're getting at here is how people respond to climate change can have unintended consequences for other goals, such as sustainable development goals. Our responses can be maladaptive, or they might not reach their intended level of mitigation or adaptation and leave us more exposed or vulnerable than we thought previously. So really adding an extra dimension to the risk. And so if we kind of walk through in the next 10 slides, I'm going to walk through a few stages of this more complex understanding of risk. coming out of the 6th assessment report, a more integrated view of risks. And I'd call this level 1. So we've taken the old 3 propeller diagram, hazard, exposure, vulnerability, and we've added one response, which is the response option selected and how that influences the risk. And I think a good example here of how this broadens the understanding of risk, not just to think about adaptation, but also about transition risks on greenhouse gas mitigation, and a broader set of things that we often hear policymakers, policymakers being concerned about with transition risk, not just reducing climate risk around adaptation, but in the process of transitioning to a low carbon economy, what other risks are we creating that might need to be managed? And so one clear example of this that's very contentious, at least in the African context and in many developing country contexts, is around land use. So we know that land use can provide large-scale emissions reductions and remove and store CO2 at scale. And we know that protecting and restoring natural ecosystems to remove carbon is a good idea, such as forests, peatlands, coastal wetlands, savannas, and grasslands. And we also know that immediate benefits of protection, by protecting high carbon ecosystems, we prevent the emissions that would happen from their conversion to things like peatland being converted to palm oil plantation. And instead, restoration, such as tree planting campaigns, has delayed benefits from a climate change perspective. It takes many decades to centuries for restored ecosystems to soak up and securely store the CO2. And so there are a lot of competing demands around this that have to be carefully managed. And we hear this especially at the moment in the context of nature-based solutions, where if you look in the summary for policymakers of Working Group 2 and of the synthesis report, nature-based solutions gets a footnote, and that footnote is basically saying this might not be a solution. And it's in there as a really big debate between certain developing and developed countries around the importance of ecosystems for mitigation, where there's concern that they could be used to justify a high consumption business as usual approach, when we also know that land use cannot compensate for delayed emissions reductions in other sectors. It's not a silver bullet. Decarbonizing electricity supply and reducing emissions in transport and industry and infrastructure, and we've got to start doing all of it immediately if we're going to meet the Paris Agreement goals. And so I think land use is a good example where this risk comes into play, because one of the things it highlights is how our responses to climate change, here talking about afforestation projects, can really lead to high risks in quite a large part of the world. So the green here is naturally grassy biomes, so that's open grasslands and savannas. And the purple color is biomes at risk of afforestation and forest expansion. So some of that forest expansion is driven by higher CO2 and changing rainfall patterns, but a lot of the purple here is places where there are tree planting campaigns potentially based on things like the Bonn Challenge and the Afforestation 100 goal related to that, or the African forest goal around that for 100 million trees, where a lot of those are being done using environmental layer targeting, but not considering the long history of ecosystems in a lot of the world as open ecosystems. And so even if we just look at South Africa here, my country down in the bottom of the map, some of that purple in that grassy biome on the sort of eastern coast of South Africa, at the bottom there is actually one of our major national parks, an important ecotourism site and a kind of iconic natural heritage site in South Africa. So really showing the risk of planting the wrong trees in the wrong places as a climate solution, and how in the policy space, having this risk understanding, that's exposure, vulnerability, hazard, and also how we respond, I think brings this richer picture of adaptation responses and mitigation responses, and their overall contribution to increasing, and in most cases, hopefully reducing climate change risks. And so another example, I think, that's gaining increasing attention attention, around risks from responses is from solar geoengineering. And so the recent IPCC assessments basically say we don't have enough research yet. We know there could be big risks. We know there could be important contributions from solar geoengineering as indicated by computer simulations that it could reduce climate hazards. And I think here is really important, where it's important to make that distinction between risk and a hazard. We hear a lot of people talking about solar geoengineering could reduce climate impacts or could reduce climate risk. But a lot of the research is still really just focused on solar geoengineering reducing or increasing a climate hazard like a heat wave or a drought or a tropical cyclone, and not a risk like numbers of people infected with a particular disease or number of species going extinct or not. And there's been very little work on that, and I think we really don't know enough about it yet. This is just one attempt that was done with a collaborator of mine, looking at the effect of solar geoengineering on exposure to conditions suitable for malaria transmission. And so the GLENS here is a solar geoengineering scenario that is applied, in this case, against a very high emission scenario to hold temperatures constant around 2020 levels, global average temperature. And what you see in the red is areas of the world where the deployment of the geoengineering scenario would increase thermal suitability for malaria transmission compared to high emissions. And the blue is places where it would decrease. And so you can see in the top panel some strong regional differences in areas that would potentially see an increased or decreased risk of malaria under geoengineering versus high emissions. Of course, we're not saying this is the only risk you're considering. A world of RCP 8.5 towards the end of the century would be very bad for many countries for a lot of reasons. So this is just one insight into the picture. But even if we look at the bottom, then we look at, okay, holding climate constant around 2020 levels versus the present day in terms of global average temperature, there's still some important regional trade-offs, like you see in South Asia, around Thailand, Malaysia, for example, where countries in the global south, developing countries, could have very, very different preferences for geoengineered climates, and assuming that using a response like this would universally benefit those who are most vulnerable to climate, I think is a dangerous assumption when we talk about these types of climate responses. And so now that was level 1, hazard exposure response vulnerability. Getting more complex, so let's call this level 2. If we look at this risk diagram now, we see that there are multiple hazards, multiple vulnerabilities, multiple exposures, and multiple responses. And this is kind of, in some ways, I'd say at the cutting edge of where the IPCC Working Group 2 assessment got to. And we hear about this a lot in social science on the vulnerability side, for example, with concepts like intersectionality, that it's not just someone's gender or the neighborhood they live in or the aspects of ethnicity, race, or age, but how all of those things intersect to create vulnerability to a particular impact. And so here's a worked example looking at the 2018 European heat wave. So it was done in hindsight, but I think it's kind of interesting to think about, because often we're just talking about, okay, what's the hazard? Well, it's heat wave. And then what was the vulnerability? Well, it's some species tolerance to extreme heat. And then what was the exposure? Well, there was the coral reef was in the tropics and was exposed to the marine heat wave. But here's really showing how you can make this picture more complex and closer to the reality that practitioners and policymakers have to manage. So there were these compounding vulnerabilities in the top right here in Europe in 2018, and again recently with heat and drought, where they've got these shallow river shipping lanes. They've got low thermal tolerance of railway lines. They also have a lot of reliance for power stations on those waterways. And those three things come together to really create a compound vulnerability across a whole range of transport and energy infrastructure. At the same time, the extreme heat can compound to lead to wildfires when it's accompanied with strong wind and drought. And in the bottom right here, you'll see a whole lot of historical responses, such as poor spatial planning, the wrong timing of evacuation orders, certain restrictions in development and spatial planning that have come together to create either higher or lower risk situations when something like a wildfire goes through. And so I think it's interesting for us to think, particularly in my group, we've been doing a lot more thinking around these compounding vulnerabilities, and this is an example from an infrastructure perspective. But if we think on a more kind of individual and personal perspective, what this map here is showing is climate literacy rates across Africa, where climate literacy is defined as, have you heard of climate change? Do you say that it is mostly or wholly caused by human activities in the sense of recent climate change? And are you somewhat aware of the consequences of climate change in the near future? And so the darker greens here are higher percentages of the population being climate literate. And you'll see in parts of South Africa, for example, it's pretty low, like under 30% on the southeast coast there, of people in social opinion surveys answering yes to all those three things. In other parts of West Africa or in parts of Zimbabwe, actually quite high. And so then digging into, okay, what is driving some of these individual differences in climate literacy? You can see here that the biggest factor is education. So people who've completed a post-secondary education, much more likely to be climate literate than those with only primary education. But then also an effective gender. So women on average about 12 percentage points less climate literate than men. And aggregating with that is if you live in an urban area, slightly more likely to be climate literate, and if you're living in poverty, slightly less likely. So again, looking at these intersecting dimensions of what makes someone vulnerable to climate change, beyond just potentially things like age or other aspects of identity, but a whole rich factor of the set of factors of the context they live in, that when we think about taking climate action for adaptation, for example, this shows that education is a really important factor, but so is education of girls especially, and looking at people in rural areas and moving people out of poverty, like doing all of those things in combination. And then I just wanted to highlight one thing here that some people have really gone wild with this kind of approach. This is the multi-sector dynamics report, which I wasn't involved in, for the US Department of Energy, trying to outline some of their research visions up to 2030, where they really got hold of this approach and took it in some interesting directions, I think, really kind of in each case, looking at different risks within the North American context and trying to build out these vulnerability and response components to be more complex and multidimensional than was previously the case, to help them understand better where they could intervene to manage risk. And so that's kind of shifting from level 2 now to the final level of complexity into level 3. And I think that's when we realize how climate change risk can flow across sectors, such as the food, water, energy, health nexus, how it shifts across time from emissions to impact back to behavior change, potentially, how it moves across space, such as differences between high emissions and high impact countries and aspects of climate migration and mobility, and then lots of different response options. In the context here on the right of a heat wave, where air conditioning is one response to reduce risk, but if that's fossil fuel, then that can increase risk in the longer term. So responses that can both increase and reduce risk. And so in the recent Working Group 2 context, and again, building on this paper by Simpson and others, kind of took this one up and it said, okay, so you've got risk that's hazard, exposure, vulnerability, and response. We understand within each of those, there are lots of dimensions contributing, but then also these multiple risks, such as a risk to health and a risk to property, can combine to make risk more difficult to manage, or risks can cascade, like in the case of risks to ecosystem from wildfire that then lead to a lot of exposed soil that with heavy precipitation can lead to risks of landslides, that might cascade into that, as happened in Australia, with a lot of that ash and soil going into rivers that leads to mass fish kills, and how this risk can propagate through a system. And I think one place where we saw that kind of recently getting more attention was the compounding of climate hazards and the COVID-19 pandemic. So this is a infographic put out by the Red Crescent Climate Center, highlighting places during the COVID-19 pandemic up to 2020 that also had some substantial climate hazard occurring, where, for example, things like typhoons and cyclones in South Asia, while people were in lockdown or trying to also do social distancing, made things like being in shelters much more difficult. Or at the beginning of the pandemic, when things like hand washing were really emphasized in Southern Africa, undergoing drought conditions, that was very difficult for people to do. So not just climate risks linked and cascading to each other, but also non-climatic and climate change risks combining. And so a last kind of IPCC graphic here that gets into this, which I think is quite nice, is this key message that with increasing warming, the risks become more complex and more difficult to manage. And I think that's something a lot of our policymakers get intuitively, but the ability to act on it sometimes, or our information around how to manage those risks, is still very much evolving. And some of them, of course, don't get it at all. And that's why we produce these kinds of graphics. But on the top here, I quite like it because it really points out this aspect of a compound hazard. So extreme heat and drought, and that being something from different from cascading and complex compound risk. So you've got a case here where you can have a heat wave and a drought happening in the same place at the same time. And that can lead to reduced soil moisture and health, which can reduce food yield and quality losses. And that risk can cascade to a risk of reduced household income over on the left-hand side of the diagram here. Up here, you can have reduced household income, but at the same time, that extreme heat can be reducing labor productivity for people who work outdoors and have extreme heat exposure. And those two things combine and compound each other, which can decrease overall quality of life, reduce household income opportunities and earning. And at the same time, the food yield losses to reduced food security are coming back at these households through increased malnutrition. And you can get heat waves on land and in the ocean, for example, in parts of West Africa, where you might have crop yield losses in maize in the tropics from extreme heat, but also reduced fish catch, which would otherwise provide important micronutrients for pregnant women, particularly zinc and vitamin A. And so this rich picture of how risks are starting to compound and cascade. And one of the findings, certainly for the urban chapter, the cities and human settlements chapter of Working Group 2, is that currently the assessment is some of our biggest adaptation gaps exist where we are not seeing and are failing to address these interlinked, interconnected risks. We're instead taking a much more siloed approach that kind of treats risk to food security, and then a different group on risk to health, and another one on risk to biodiversity or risk to energy. And the biggest adaptation gaps are the ones where those come together, and our current responses are kind of not seeing that bigger puzzle, and instead things are falling through the cracks. So for the last bit of the talk, I'll just focus briefly on one narrow lens on what we can do about this. And of course, like a major part of it is having more transdisciplinary and interdisciplinary approaches, more integrated approaches to understanding and responding to climate risk, more cross-sectoral discussion, both within government agencies that manage these types of risks, as well as the private sector. But I'm going to take a slightly different track here and talk about what role kind of equity and some of our approach to research as researchers coming from a South African perspective, how we've done some of this. It's just one entry point. As I said, there's a lot of things from climate finance to more integrated and cross-sectoral approaches that need to happen to address these issues. But one part of this that we found quite important with policymakers here and in African context is really approaching it first from a step of just knowing our history. So these are statistics many of you are probably familiar with. This is from the most recent IPCC synthesis report, but just showing kind of historical inequities in regions that have contributed to greenhouse gas emissions over the last century and a half. The green color here being from fossil fuel and industry, and the gray from land use change. So there's quite a lot of uncertainty on that land use change part, but on average, again, we hear this a lot, but Europe and North America, particularly North America, contributed the lion's share of greenhouse gas emissions over the last century and a half, and African countries only 7%. Where South Africa is a slight exception there. We've got a massive coal baseload, but also currently struggling to provide reliable energy. But most of the rest of the African continent contributed relatively little. And so coming in through this lens is a very important way to open this discussion about complex risk. Because if you just immediately often kind of go first for the solutions, this aspect of equity and justice that's so important can get left behind. But if we're talking especially about how those vulnerabilities are intersectional, they come from lots of different aspects of people's backgrounds, identities, the context they're in, then this is one important part of that. Who so far has benefited or had the burdens of the causes and consequences of climate change. And so here's another IPCC graphic that didn't make it into the summary for policymakers, but sits in the underlying section 2 of the report, where it shows here on the x-axis is the average national vulnerability from various risk indices. This isn't specifically vulnerability to climate change, it's vulnerable contexts overall, such as being fragile, conflict, and violence-affected states. But there is quite a striking relationship here with emissions along the x-axis, where countries that are more vulnerable have, on average, much lower emissions per capita. And so the message coming out of this is that many of the most vulnerable have, up to now at least, contributed the least to greenhouse gas emission. I'd say for me, one kind of positive aspect of this figure is we see that there are some down in the bottom left here where countries are pretty low vulnerability and they're also really low per capita emissions. So that shows we can do this. We can be less vulnerable and lower emission economies. But the kind of general pattern going through here of decreasing vulnerability being associated with higher emissions, and that inequity in the causes and those facing the risk of climate change. And so again, just emphasizing in this richer risk picture where response is a key part of it, as well as vulnerability, exposure, and hazard, that this is what holds up a lot around equitable burdens and fair shares, and really having a focus on these things, I think, continually is frustrating and slow in some of the negotiations, but also it's really important for building trust and making sure that the benefits and burdens of climate action are shared equitably so everyone can take faster action on the problem. And it's not just in the economy, but also in our research communities. So this is an analysis done by Indra Overland and others. My lab has been involved where we use the Dimensions database to track research spending globally on climate change over the last 30 years. This is by agencies that report to Dimensions. So it's things like national research foundations. It's some of the larger philanthropy groups. It's some big development funding agencies. And so it captures a fair proportion of global research spend. And if we look over the last 30 years, the blue line there is funding allocated to climate change research globally, and the orange on the bottom is the proportion, the percentage that went to Africa. Well, it's the total for Africa. And when you do the percentages, it's only 3.8% of global climate change research funding has focused on Africa since 1990. So that's totally incommensurate with how vulnerable we know the continent is. And I think what's even more interesting is that when we look at where did that 3.8% of funding focused on Africa go, well, almost 80% So most of that 3.8% actually went to institutions in the EU and the US to study Africa rather than going to African institutions. So if you look on the right-hand side here, the UK, the USA, Germany, Sweden, you've got to go all the way down to the 9th and 10th ranked. Kenya and South Africa are the first African countries that make it into the top 10 of countries that have research institutions receiving funding for climate change research on Africa. So there's really big inequity in Africans not currently and historically not having the research resources to develop a richer understanding of risk in their context, at least from a research institution perspective in academia, and develop solutions. And so one of the consequences of that, if you look at this map, is that most African countries have very low levels of adaptation research in the published literature, right? If you look at South Africa, again, there's an anomaly here, but the lightest pink colors are less than 100 papers published over the last 30 years on adaptation about something in those countries, adaptation about something there. Whereas in North America, China, India, like many over 1,000, the scale goes up to like well over 10,000. And so if you looked at number of first authored papers by a researcher in those countries, then it would look even more stark. Like many of these African countries would be a zero, as in the last decade at least, there hasn't been a first authored paper by a researcher from that country on climate change adaptation in that country in the peer-reviewed literature. And so these inequities in funding really shape who has power when it comes to addressing the risk, right? You end up in a UNFCCC negotiation or an IPCC assessment, and the expert on a topic, as far as the peer-reviewed research sits, is often located outside of the country, not from that country, doesn't necessarily have the trust base with those policymakers. And in the back of their mind, some of them are thinking, maybe you're from a geopolitical region that's caused a problem more than we have. And so it really requires this like very rich, I think, awareness of our positioning within these dialogues as scientists to try and be effective enablers of climate action. So on that, just a few thoughts to end here. I think one which really stuck out from the mitigation side in the IPCC this time, and many of you might be aware of this, but is scenarios. Some developing countries, India, for example, really stuck certain scenario discussions for a very long time. And one of the reasons they did was around issues of equity. So most global modeled emissions pathways do not make explicit assumptions about global equity and environmental justice. So Jason Hickel in the UK and others have written about this, where some of the kind of sustainability pathways in the SSPs still have very large income gaps between developed and developing countries by the end of the century. Even though they've held global warming at very low levels, they're not necessarily focused on a just transition. And in contrast, other parts of the IPCC assessment are saying things like this, where it's adaptation and mitigation actions that prioritize equity, social justice, climate justice, rights-based approaches, and inclusivity lead to more sustainable outcomes. They can reduce trade-offs among different goals, and they can support transformative change that advances climate resilient development. So that's quite a mouthful, but again, no accident that equity is first here, but then these other concepts are also equally very important, rights-based approaches. And then another finding from the SPM is this attention to equity and meaningful participation of all relevant actors. And I think that the really key important part here is partly around building social trust and the equitable sharing of benefits and burdens of mitigation action. And you could say the same about adaptation action, I think, that can deepen and widen support for transformative changes this decade. And so a kind of final couple of images my group's been using through the process to try and understand some of these risks and how to respond to them is One is this idea of a decolonizing ecology, which I think we could talk similarly about in climate science, which is really, I've talked just briefly about knowing our histories here, and being able to position ourselves in those, but also decolonizing access. So that's not just accepting a kind of post-colonial status quo of research resources in developed countries being different from developing, but really how can we actively undo some of those patterns? And similarly about expertise, and then about doing our own work to understand those differently, decolonize your mind, but then really doing ethical research here. This is ecology, but climate science the same in much more inclusive teams. And so I think with that, I'll end. There is a link to a climate change sci-fi game, which I'll just kind of, I can share it later, but I'd rather get time for questions. We started a bit late, but basically just trying to put some of these into practice through work at the National Social Environmental Center at the University of Maryland, which really, it's a lot of time, not so much on the science initially, but just in these rich kind of imaginary conversations with policymakers, but also science fiction authors and others, trying to kind of shake ourselves out of typical ways of doing things and imagining alternative ways that the world could be, and ending them with things like a group art performance, right? That kind of gets people thinking more creatively, but also builds high levels of group trust. And so this is a link to one of those games, which I could share in the chat with anyone who's curious. And yeah, happy to answer any of your questions now.
Okay, thank you very much, Chris, for that really intriguing talk. So yeah, let's go ahead and open it up to questions now. So if you have a question, you can do one of two things. You're welcome to put the question into the chat, or you can use the raise your hand function. And as I said earlier, address Chris directly. Okay, so I'm seeing that Peter Lawrence has his hand raised, so please.
Chris, thanks a lot for this. It's amazing talk. It's a little overwhelming, you know, as researchers, we try and take on the whole sort of physical climate system and try and understand scenarios and everything else. How do you think we go about trying to improve the research we're doing so it becomes sort of like this actionable and useful sort of foundation that we can help guide decision makers? Because it's overwhelming and it's challenging for us as like researchers.
Yeah, I'm still trying to figure it out myself. So this talk was a nice opportunity to bring something together. I agree, sometimes it can seem really overwhelming. I think a few things that have helped me, it's not that these are the best solutions, but sort of reflecting on some of my own practice in the last 4 years. One, I think, is if you're wanting to work quite closely with decision makers, being able to allocate the time to that. Like I've got a position where I'm just full-time research. I don't have to do teaching, fortunately. And I'd say probably all the time I would spend on teaching is spent just being kind of available on WhatsApp for occasional chats with decision makers, showing up at functions where they're showing up, and building those levels of trust, particularly in the kind of climate negotiation space around climate finance, where a lot of things are pretty contested, and it takes a while, can do, to build up the trust. The other thing I'd say is, in terms of understanding the risk, is it really helped me to get that richer risk perspective of, because you're kind of thinking like, okay, what we got to do is reduce vulnerability, and someone else is like, if I do this option, then I might not get elected next cycle. And it's like, that's also in my head now a climate change risk in a way, but they're thinking about, okay, what's the risk if I deploy this response? Not so much like how much do I reduce risk for those vulnerable people necessarily. And so I think just empathizing in that like richer picture of risk helped me a lot to find moments when I could sort of put suggestions on the table that there's no guarantee someone will actually take them, but at least they get a bit more attention, I feel like, than they used to. So yeah, hang around, build trust, but then I think that richer picture of risk when it comes to the policy space has definitely helped me empathize more with the decision makers and be a bit more helpful than I think I was previously, where I was more like single issue focused.
Hey,
I will
thank
add
you.
one last thing.
Oh,
Sorry, Peter. Just because it came to mind, I think stories are really powerful. And so I think often something that where I think part of the physical hazards community in climate change has been leading on some of the complex risk stuff is sometimes when they say like, you know, the probabilities here are still really difficult. We haven't fully worked them out, but we can tell you a story about a plausible future, really bad climate hazard. And I think that's also a very effective way to do it. Yeah, sorry.
Thanks
hey,
so
no,
much. That's great.
yeah, thank you. Do we have any other questions? I'm seeing that Eric put the link to the Cli-Fi game in the chat. So thank you, Eric, for doing that. So I'm not seeing any other questions, and I have one. I just like to pose this, and I'm also going to put it in the chat because it's I can be a little bit long-winded, but I'm wondering if you think that any of the inequities or just risk in general for a lot of these already vulnerable communities that don't have the historical responsibility are further compounded or exacerbated given the inequities in kind of the historical development and application of the instruments that are largely used to understand climate change. Because a lot of the CMIP models, for example, decisions about CMIP experimental design, things like that, it's largely the global north, right? That's making these decisions about what we want our models to be able to do, how they're going to be applied. And this seems like it can exacerbate risks for certain communities whose perspectives have not historically and currently are not being represented in a lot of these instruments to design and then apply the instruments we use to understand climate change. I'm just curious if you have any thoughts about that and whether or not some of these current efforts where people just want to apply the models and provide broad data to these communities, thinking that that's a solution that can further increase risk.
Yeah, I think you're definitely hitting at an important issue there. I'm not sure I have quantified examples of if that dynamics increased or risk, but I think in the kind of spirit of a more equitable approach, I showed that funding graph for a reason, and I think it's really important for us to think about how can we be more inclusive in addressing risks in our research by being more inclusive in the actual research community, where I think there's been an increasingly good trend and a lot of good work done in climate science around data being open access and easier to download and get hold of, etc. But I think there needs to be a lot more done to open up the decision-making spaces when we set scenarios, for example. So running a CMIP6 model, I don't know, that I think it would be good to have more inclusivity there in how certain things are done. But I think particularly when it comes to stuff like scenario MIP and the SSPs, that are what a lot of policy communities really focus in on for understanding different risks, right? Those have historically been not that inclusive when it comes to who gets to contribute to the design of those scenarios of a more dangerous or a better future, as simplified as they get in the policy discussion, which is, I know they're not that simple actually in the design and the academic side of it. There's much richer framework than that, but those communities have historically not been as representative of a lot of the people living on the front lines of climate change as they could be. And so that's a challenge, I think, to a lot of the scenario community, because it's not easy to do that. But I think to be increasingly relevant for risk reduction and not have situations like happened during AR6, where you've got major global south countries kind of throwing out aspects of scenarios because they feel like they don't take equity enough into consideration, and therefore why should we even have RCP 8.5 or SSP 126 in this map in the first place? Just cut it out. And that's not really a climate science disagreement, right? It's more about how did we do the social science linking up with the climate science, and can we do that in a better and more equitable way? I think we can, but it requires some transformation of the funding agencies involved, so that it's not just about sharing the platform that's like, okay, you can use this data we generated and run your analysis on our platform, but it's like sharing the thought leadership that says, okay, when we're building the experiment in the first place, the scenario, how do we design that differently to be more equitable? And I think there are good examples of that arising, but we need more of them. Yeah.
Okay, thank you. Are there any other questions? You see Peter put a follow-up comment, I suppose, in the chat. We are actually coming to the end of the hour. So I might just ask us to thank Chris one more time for joining us, especially considering how late it is in South Africa right now. And we will see you next week for what will be our final seminar of the season. Thank you.